So when we started fractions, before we started adding and subtracting fractions, we talked about finding equivalent fractions. The first thing we did was make a number line to show equal fractions on a number line. The word equivalent is the same thing as saying equal. We talked about how fractions are part of a whole. So it's everything that would be, for example, in between a 0 and a 1, or in between a 0, a 1, and a 2. It's all those little fractions of a whole. So the first thing we did was we divided this in half, and we found that we've got 2 pieces to make it whole, which represents our denominator. From here to here is 1/2 of the whole. From here to here is 2/2. So then we thought, okay, could we make another different fraction? Well, let's say we cut our halves into half. Now we have 1, 2, 3, 4 pieces to make it whole. So now my new denominators would be 4. This is 1/4, 1 2/4, 1 2 3/4, 1 2 3 4/4. What if I again divided these into half? 1 2 3 4 5 6 7 8. Now my denominator is going to be 8. Oops, I forgot some. 1/8, 2/8, 3/8, 4/8, 5/8, and we should see a pattern. Now these are all fractions that even though the numerators and denominators are different, we've proven that they are actually equal. So then we took a picture. For example, if I had 1/2 compared to, let's say we're going to compare it to 4/8, we're going to prove that in fact they are equal. So my denominator tells me how many pieces make the picture whole. My numerator tells me how many are shaded. So now we need to divide this whole into eighths. One, two, three, 4, 5, 6, 7, 8. We're going to shade 4. Because up here it tells us 1/2 should equal 4/8. We're going to see if we're right. And in fact, 4/8 does equal 1/2, again proving with a picture that these are equivalent or equal fractions. This lesson is very important on the basics of adding and subtracting fractions. We have to be able to make equivalent fractions when trying to find common denominators. So we went from the number line to the picture. Then we decided, all right, well, let's prove it again. If I have 1/2, and let's say I pick a denominator of 4. To go from 2 to 4, I multiplied by 2. In order to make these equal, what I do to the bottom or what I do to the denominator, I must do to the top, the numerator. So if I multiplied by 2 to get to 4, I had better also multiply my 1, to get my numerator, proving again that these truly are equivalent fractions. Let's pick 3/4. I'm going to make my own equivalent fraction, so I'm going to pick any number. Let's say I multiply by 6. 4 times 6 is 24. What I do to the bottom, I have to do to the top. So right now, 18/24 is an equivalent fraction. Let's say I want to do it the other way, because if I'm finding equivalent fractions, I can only multiply or divide. So let's say I start with a rather larger number, and I've got 2/10.